Hello, everyone. I am Musanna Galib. I am a PhD candidate in Mechanical Engineering Department at the University of British Columbia, and the title for my Open Life Science graduation program is Bridging Quantum Mechanics and Machine Learning, Developing an Open Source Software for Efficient Data Processing for Advanced Research Inclusivity. So what is this project about? In this evolving field of material science, every year there are lots of new methods and tools are coming, which is very difficult to keep track with all the tools. Therefore, my unique value propositions for this project is to come up with a simplistic open source pre and post processing tool, which will help to data pre-processing, data post-processing, so that researcher can focus more time on actual physics of the problem rather than doing the processing of the data. And this software will be very simplistic so that the researchers who have issues like geographical isolation or first generation researcher with lack of information about this field will be able to use this tool as their starting point, and which will lead them for a smoother research in the future. So the software is called AtomProNet, which is a short form of atomic data processing for neural network, including 4 modules, starting at data collection, data generation, then post-processing, and then visualization. So all of these 4 modules are integrated and dependent on other projects and other softwares. And they are also open source, starting from Material Project and then Quantum Espresso. Now, this project I divided into 2 stages. The first step is to build the software architecture and testing. Here you can see the GitHub page with the software architecture already built, and you can check this software in this GitHub link with an extensive documentation starting from installation, software overview, how to use this package, cite this package, and the code of conduct. And also it is under MIT license, therefore it's uh, open source and publicly available, and can be used in any academic project. On top of that, I also created an tutorial, Colab tutorial. The link is given here, and this tutorial includes several examples which will make the learning process for the researcher seamless. And the second step is to reach the researchers in this field. Therefore, I am conducting tutorials and survey. Starting with tutorial, for tutorial, I already secured 3 tutorial sessions, starting at University of British Columbia, and then University of Alberta, and then University of Calgary. Here you can see one of my flyer for the presentation. And the second stage is to do a global survey, and this survey report will include the view of the researcher all around the globe about the progress and bottleneck in this field. And I also added the survey link here. Please feel free to take this survey if it is related to you. Finally, I'm trying to make my DRI EDI project fair. That means findable, accessible, interoperable, and reusable, which is ensured by making the code available through GitHub and Google Colab so that it is findable and accessible. Data will be available through GitHub and Genero. Again, it will make it findable and accessible, and this will be under license, which is MIT license. For this, it will make it reusable and interoperable. And the article with the survey data will be included in an article, so that researcher can understand what are the progress and bottleneck for this problem. And I would like to thank everyone, starting from Digital Research Alliance of Canada for funding this project, and Open Life Science for conducting the tutorial sessions. And I would be happy to connect with everyone. And thank you very much for listening my presentation.